So today I'm going to be talking about the sliding filament theory, which is also known as excitation-contraction coupling. And this is a concept that I've had a hard time wrapping my head around, so something that helps me think of it is it is the rapid communication and translation between an electrical event happening on the plasma membrane of skeletal muscle turning into the mechanical event of the contraction of that skeletal muscle. So I'm going to start with the neural origin of this whole process, which is the generation of an action potential by an alpha motor neuron. That action potential, once generated, allows for the release of acetylcholine, and acetylcholine will bind to receptors on the sarcolemma, and that causes the depolarization of the whole membrane. That depolarization signal will get sent down T-tubules deep into the skeletal muscle fiber, and it signals for the sarcoplasmic reticulum to release calcium. And I should have stated to begin with that this whole process cannot happen without calcium made available by the SR, or the sarcoplasmic reticulum, and also the presence of ATP. Those two things are essential for all of these things to occur. So, like I said, our depolarization signals the release of calcium from the SR, and that calcium will bind to troponin C. When troponin C gets activated, its job is to basically move this giant molecule called tropomyosin out of the way. And this tropomyosin, basically in its inactive state, it blocks the active sites on actin. It prevents myosin from binding to actin. So that release of calcium allows troponin C to help move tropomyosin out of the way and expose the active sites on actin for those myosin heads to then grab onto. And this is where ATP comes in. You have to have ATP present for that myosin head to be able to grab onto the active sites on the actin. The hydrolysis of this ATP, so the fact that it has been split into an ADP and an inorganic phosphate, is what allows the myosin head to be like cocked back in a way where it can grab onto the actin and form like a cross bridge formation that's really tight and strong. So the presence of that ATP allows that cross bridge formation to be so tight and strong, which leads to the power stroke. So ADP is released from that cross bridge formation, and it allows that sliding motion to happen, which is effectively the myosin head pulling down the actin up to another active site to allow for this sliding to continue happening. And again, that presence of calcium binding to troponin C is what allows the tropomyosin to remain out of the way, to allow for contraction of skeletal muscle. It is important to note that the enzyme that allows for that hydrolysis of the ATP is called myosin ATPase. The enzyme myosin ATPase is what allows for that hydrolysis of ATP, so you can get from ATP to ADP and an inorganic phosphate, and that ATP is what's providing the energy to basically cock back the myosin head so that it can do a power stroke and get to the next active site on actin. If I'm being honest, I don't really love any of the diagrams in our textbook. I think this one is a good visual for just like thinking of it, in that this is the thick filament of myosin, this is the thin filament of actin. These are the myosin heads, and they are grabbing onto those active sites on actin. You have troponin, which binds to calcium, which keeps that tropomyosin, that thin orange strand, out of the way for this binding to occur. So this is a nice visual for understanding how the strands are sliding past one another, and the myosin is power stroking, moving up the actin to allow for contractions to keep occurring. And to end off, I also enjoy this diagram because I feel like it kind of shows from top to bottom the steps. I like to think of this being the top of the cell, the action potential propagating down the T-tubule, which allows for the release of calcium from the SR. That calcium binding to troponin is what enables troponin to move tropomyosin out of the way and allow for these myosin heads to make cross bridge formations with actin. And I hope that that was helpful.